How we established slash decided on how to create the project was due to primarily calculations. What we did is using the given data, such as the horizontal distance d, which we were given 2.94 meters, and the vertical height, which we decided on making, which was the d sub a 0.78 meters. Also using the mass of the ping pong, 1.7 grams. From there, we calculated the given velocity and the angles of which the ping pong ball needs to traject, which and what kind of force we needed to do. With that, as we calculated, we knew that the d of a equals 0.78, and we could find the initial velocity using one of the equations. Then we found the velocity, the y velocity, which was 3.900998712, and then we plugged it in back to find the the velocity of the initial project. With that being said, we also calculated the angle of which we need to traject the ball in order for it to go the maximum satisfactions we could, and we got that it was 59.0362436 degrees, and this would be the ideal situations. Then we built our apparatus. We understood that the idea of the angle, however, the amount of force was unknown, either ending too short or too long. So the idea of the applied force was a test, which required a bunch of testing and manipulating. However, when finished, the apparatus worked perfectly, and we nailed all satisfaction. Also, for our calculations, we calculated the data needed without any added forces on it, such as air resistance and wind, which could be a huge factor. Meaning that the applied force and the only applied forces due to on the ping pong ball would be the applied force from the original apparatus and the gravitational force. Air resistance was also applied, and so was wind, depending on the environment, but we could not account for that because there would be too many small calculations. However, we did adapt to the environment, and we tried to do it inside a building to maximize it like the actual project day. And therefore, the end result was that we actually needed to change the angle of which the ping pong ball was going to traject. Originally, it was going to be 59 degrees, but now we made it a 45-degree angle, and we realized that the applied force for us was going to be the sixth nailed in. And that's how we did it. We just tried our best, and we also did a lot of tests.
In order to calculate the resultant velocity, horizontal velocity, and the vertical velocity with which our ping pong ball was launched, we used measurements from our actual working apparatus launcher. In order to test and measure, we conducted 3 trials. We conducted these trials using a testing room we assembled in one of our houses. In order to make this room, we first measured the distance from beginning to end, which is 2.94 meters, and marked it with tape on the ground. Then we marked on the wall the location, so height and distance, of where the middle of the hula hoop will be. This was 1.30 meters from the start and at a height of 0.78 meters. We marked the wall with tape ranging from 0.70 meters to 0.90 meters, so we get the most specific measurements possible. Adding on, we marked on the ground a 10 by 10 square, which is the final target we want the ball to hit. For all 3 trials, we used 2 phones to time it and another to record using slow motion, so we can go back and see exactly where on the wall the ball passed, so we can write down the exact height. We had the help of family members to help record time and have extra eyes to help us get exact measurements. The amount of time we measured was the number of seconds it took since we launched the ball until it hit the ground, hopefully within the 10 by 10 square. The distance is the distance from the beginning to where the ball landed, and finally, the height is the highest point of the ball, which should be right where the imaginary hula hoop would be. For the first trial, the time was 0.61 seconds, the distance 2.86 meters, and the height 0.79 meters. For trial number 2, the time was 0.67 seconds, The distance was 2.67 meters and the height was 0.76 meters. For the third and final trial, the time was 0.47 seconds, distance 2.64 meters, and the height 0.78 meters. Finally, our average overall measurement for time, distance, and height are 0.58 seconds, 2.73 meters, and 0.8 meters. These average measurements are the ones we use in our calculations, which we will talk about in our next answer.
After we did trials using our built apparatus, we took the average of 3 trials that we did and redid our calculations in order to compare it to the calculations we did earlier using the measurements that were given. For the time it took for the ping pong ball to launch and hit the ground, we got an average of 0.58 seconds. The average horizontal distance that the ping pong ball went was 2.73 meters. The average distance due to acceleration was 0.78 meters. We did our calculations by finding the vertical initial velocity and horizontal velocity of the trajectory of the ping pong ball in order to later find the resultant velocity. In order to find the vertical initial velocity, we used the equation d sub a equals final velocity squared minus initial velocity squared all over 2 times the acceleration. We knew the distance due to acceleration was 0.78 meters. The initial velocity was 0 meters, and that the acceleration due to gravity was negative 9.8 meters per second squared. We then did the calculations to find that the initial vertical velocity was 3.9 meters per second. In order to find the horizontal velocity, we used the equation velocity equals distance over acceleration since the distance over time, since the horizontal distance is constant. After calculating, we got the horizontal velocity to be 4.70 meters per second. We then used the Pythagorean theorem to find that the resultant velocity was 5.23 meters per second. Finally, we used the inverse sine to find that the angle we need the apparatus to be is 48 degrees. This is calculated without any account for air resistance, so the calculations would not be exact for our project. After we did these calculations, we compared them to our original calculations in order to see what we can change about the project to have an accurate launch. We brought our angle down to around 45 degrees in order to satisfy the distance during acceleration of the trajectory, which was 0.78 meters. In order to find a perfect horizontal distance for our ping pong ball, we had to test around with the applied force. We tried different types of string and different approaches, such as using a thin thread tied to the string in order to improve the consistency of the distance. We created different holes in our PCP pipe in order to have different applied forces to test. Finally, we found what would be perfect for our launch by using both the calculations from the trials and from the requirements that you gave us.